In this video, we'll be looking into further how medical images, or X-rays, are produced. X-ray images are formed from the reduction of the intensity of the X-ray passing through a substance. This decrease in the energy of a substance is called attenuation. So, an X-ray passing through, say, muscle in your body is getting scattered and or absorbed by the tissues that make up the muscle. If we have a bone or a piece of metal in our body, the X-rays are hitting the bone and then they're getting scattered or absorbed by the bone, and so there's not as many passing through the bone onto the photographic plate behind it. So the processes that stop or reduce the intensity of our X-rays is called attenuation. So, like I said, different materials cause different amounts of attenuation. So, skin and muscle in your body is mainly made up of organic molecules. So this is carbon, hydrogen, oxygen, nitrogen. These have a relatively low atomic mass. So carbon has an atomic mass of 12, nitrogen has 14 atomic mass, and oxygen has an atomic mass of 16 grams per mole. So, these are relatively low in comparison to something like iron. If I had, say, some iron pins, or a piece of, say I just got a nail stuck in my arm somewhere and I couldn't quite see where it was. I then had an X-ray to see where my nail actually was in my arm. My nail is made out of, say, iron. Iron has a higher atomic mass than what, say, carbon, nitrogen, oxygen is. So, on the X-ray photograph, when the X-rays pass through it, there's going to be more scattering and absorption by this nail compared to the tissue around it. So this scattering and absorption of the X-rays reduces their intensity. So that means there's less going to hit the image behind it. If there's less, there's going to be a brighter spot. If there's more X-rays hitting the screen, we get a darker spot. So this is why bones show up as a light spot on an X-ray, because bone is mostly made out of calcium. Calcium has a higher atomic mass than what the tissue around it does. So carbon is 12, calcium is much higher than that. It's around, I'm trying to think, maybe 40-ish. And this then causes the bone to show up in a light spot on the screen, whereas all your arm, so all the tissues of the skin and the muscle show up as just a darker spot. There is still some scattering caused by and absorption caused by your tissue, so you can still see the outline of your tissue, generally on an X-ray, compared to just the X-rays going straight past it. So, attenuation is the scattering or absorption of an X-ray. It reduces the intensity of it. And the higher atomic mass of a substance is going through, the higher the attenuation. The penetrating power, or the hardness of an X-ray, needs to be taken into account when we make a medical image. So the hardness refers to the energy of the photons from the X-ray. So the energy is related to the voltage, because the higher the voltage, the higher the kinetic energy of the electrons, and therefore the higher the energy of our photons are going to be. We also have higher frequencies. So hard X-rays have high energy photons with a higher frequency. Softer X-rays have a lower energy photon and therefore also a lower frequency, because the voltage is related to the frequency. We saw that in the last video. So hard X-rays are around about 100 to 150,000 volts, the potential difference between the gap, and the potential difference in a soft X-ray is about 50,000 volts. So depending on what we want to look at, depends on what the hardness of our X-ray needs to be, or the penetrating power. So, If I was looking for a cancerous growth in, say, a liver, the liver is made out of mainly carbon, nitrogen, and oxygen, so our organic molecules, organic compounds. And the cancerous growth is going to be very similar, but it's going to have a slightly different density. So you want to have a softer X-ray. For soft tissue, you want a softer X-ray, so you're not having all the X-rays penetrating through the material and just going straight to the plate. We want it to be stopped by different densities of our softer tissues. So we need a lower voltage, therefore lower frequency and lower energy photons. If we want to look at bones, we would use a higher energy photon, so a higher hardness. Increase the hardness of the X-rays, you increase the potential difference, you increase the maximum frequency of the photons, and you also increase the energy of the photons. So the hardness is the scale of the penetrating power of the X-rays, and you need to be able to change the hardness depending on what sort of material you want to look at. So if you had something in your lung, you'd want to look at a softer X-ray to get the growth in the, or whatever it is in your lung to show up. If you're looking at bones, you just use a harder X-ray. To produce a clear image, we need to adjust the exposure of the X-ray. The exposure of an X-ray can be thought of very similar to the exposure of a camera. So, if I was taking a picture at night and I didn't use a flash, I would have to hold the exposure open for longer, so then more photons move into the camera lens and then onto, say, the film, or in this case the digital camera, so the sensor. This produces the brighter image then, so allowing more light to enter into the camera over a longer period of time. This can have its issues though. If you hold the shutter down so the exposure is open for longer, and you're holding the camera, you're moving slightly all the time, so the image you're going to get is blurred. So this is the same with an X-ray. The exposure on an X-ray is how long we're having our X-ray machine on for to take the image. If we have the machine going for longer to get our image that we want, we're going to have a blurring effect because the patient is moving. This produces a blurry image, and then we get a very poor result, and you won't be able to see what's actually wrong with your bones. The way that we can fix our exposure time on a camera is by turning the flash on. By having the flash on, we're increasing the intensity of the photons of light coming into the camera. We can do the same sort of thing with an X-ray. If we increase the intensity of the X-ray photons, we can reduce the exposure time necessary because we have more photons. So the way we do this is we adjust the voltage on the tube current, or what we know as the filament current. So if we increase the voltage on the filament, we have more electrons leaving the cathode. If we have more electrons, we're going to have more intense photons, or more photons. The more photons we have, they still have the same energy as what they did before, it's just more of them. So, the more photons we have, the brighter the image will be. So, we can have our hardness, or our energy of our photons, whatever we want to look at, whatever image we want to look at, but we can increase the intensity of these photons by increasing the tube current, or the filament current. Changing the filament current increases the electrons, which produces more photons. The photons still have the same energy as what they did before. To change the energy of the photons, you need to change the high potential difference. This is the low voltage. So that's the difference. So we're increasing the intensity of the photons. We're not increasing the energy. So the key points from the video. Attenuation is the reduction in the intensity of a X-ray photon as it passes through a material. This is caused by scattering or absorption of the photons. In an X-ray image, attenuation plays a part in what we actually see on the film. X-rays are scattered or absorbed by different materials, so they're attenuated by different materials. Soft tissues, so muscles and skin and things like that, are less likely to attenuate the X-rays or absorb the X-rays compared to what a bone or a titanium rod is in your body. So this is why we see images of our bones and, say, metal rods in our body clearly. The bone is more likely to absorb or scatter the X-rays, reducing the intensity of the X-rays actually reaching the film plate behind it, which then causes a bright spot. X-rays that are passing through our tissues and hit the plate behind it with higher intensity cause the darker spots. The hardness of our X-rays is important. If we want to look at soft tissue, for example, we need to reduce the hardness of our X-rays. We don't want it to be penetrating straight through all of the tissue. We want it to clearly see, to say the tumorous growth or the cancerous growth on a soft tissue, we need to reduce the hardness. We do this by reducing the voltage. By reducing the voltage, you reduce the frequency and the energy of the photons. So the maximum frequency and the energy of the photons. By increasing the voltage between the cathode and the anode, you are increasing the hardness or the penetrating power of our X-rays. This is used for, say, if you're looking at bone compared to looking at soft tissues. The exposure time is needed to create a clear image. If we have an exposure time that's open for too long, so we're exposing a body part to our photons for too long a period of time, we could end up with a blurred image because the person could move slightly. We want to reduce the exposure time as much as possible to reduce the possibility of blurring. So the way we do this is we increase the intensity of the photons. We increase the intensity of the photons, we can decrease the exposure time for any given hardness. So to increase the intensity of the photons, what we need to do is adjust the voltage of our filament. If we increase the voltage of the filament, we get it going, heat it up more, we get more electrons coming out of the cathode, so therefore we have more photons reaching our image in the end. So this is not the voltage that changes the hardness, this is a voltage that changes the intensity. So there's a difference between the two. So this is how X-ray images work.